Hello, everyone out there in Fusion 360 land, and welcome back to another live stream of Fusion 360. Today, I'm your host. I am Jason Lichtman, Technical Specialist for Design and Manufacturing here at Autodesk. And on the keyboard, we have Aaron Magnan, Technical Marketing Specialist Extraordinaire. And today, we are going to be covering what I'm calling Deriver's Education. As you could tell, I love my puns. We're going to cover the derive command, what it does, what it doesn't do, how it's supposed to work, and how you can use it even though it's not exactly supposed to be used that way. I'm going to cover all of the ins and outs of the derive command. And if you don't know about the derive command, it was new in October of 2018, so about a year old today, and yet a lot of people still don't understand what it does or how to use it. And so I'm going to show you exactly that and more today. I'm excited, so let's get into the good stuff. I'm going to go and show you my Fusion 360 screen. There it is, almost. There it is. And we're going to cover the first thing, which is what was it intended to be used for? What is the officially correct workflow for the derive command? So think about it this way. You designed a part. Actually, no, somebody else designed a part, and you're going to go and manufacture that part. You're going to go and add the toolpaths. You could actually add those toolpaths to the original design file, but there are going to be some challenges with doing that. In particular, because the engineer that created that part might end up actually using that part in a variety of assemblies. And if I, as the machinist, end up adding a bunch of stuff to this file that's really only meant for machining, it might clutter up the file if the engineer is going to go and use it in other assemblies. So as an example, here you could see a dog bone part, pretty basic, nothing too special here. It was designed in Fusion 360, so you could see the sketch, all the extrudes that created this, as well as some chamfers and some other things as well. And if I, as the machinist, go and add additional bodies, those bodies could be fixtures, they could be soft jaws, they could be the vise that I'm going to hold this in. It could be any number of different things. And if I add all of those bodies to this file, I'm going to end up with something like this, where maybe I have also the initial stock as part of this model. Maybe I have a separate set of stock for setup number 2. Maybe I have all different kinds of other stuff. And if I put all of this in and I save this file with all my changes, and I guess I should show you first that I also add my toolpaths themselves. Here you could see all the toolpaths I added for this part. And we can go and simulate that, and you'll see machining this part as well. And I'll skip through it a little fast, but you get the idea. So the engineer created the part. I, as the machinist, add all my toolpaths and other bodies and other components, a bunch of other stuff. I'm going to go and close that out. We're going to go and save this file. And we're going to go and say here that we added toolpaths. Perfect. So now let's say I'm the engineer again, and I want to go and use this bracket in some other assembly. I could go and create a new assembly or a new design. We're going to go and save that design, and we're going to call this example assembly for now. And when I go and I insert that bracket into this assembly, keep in mind that it's not just going to bring in the bracket, it's also bringing in the other bodies that the machine has created. And that could be a little frustrating for me as an engineer, because all I really want to see here is the object itself. And because we don't yet, emphasis on yet, have the ability to edit components inside that are referenced from inside an assembly, I even can't hide these other bodies. And that could be really frustrating for me. So what I'd probably have to do is go back to the bracket, hide the other bodies, save the file, and the description there is really just hid manufacturing related bodies, something like that. Now it's going to make another version, which may or may not be a big deal. And I'm going to bring version 4 of the bracket into this assembly. I could just go and update that. And now I'm going to see just the body that I care about. So long story short, if you add your toolpaths and some other stuff to your design, it could clutter up your design. So this is where the derive function or feature really comes in handy. So what we could do is we could have something like the bracket, and it could just be the bracket itself, so nothing else. And what we're going to do is we're going to simulate that by getting rid of all this other stuff here. I think it's all of this stuff here. Let's get rid of that. Perfect. So now we have our part by itself. I'm going to go and save this design, and we're going to say got rid of manufacturing stuff. So now I have my bracket. It'll be version 5, and it's just as the engineer intended. So no manufacturing toolpaths yet, it's just the design. What we could do is we could go into a new design, and we're going to say, let's save this file right off the bat. And you do have to save this file for you to be able to derive. Actually, I'll just show you what you're going to get if you try to derive right away. If you say insert a derived component, it'll tell you that it requires saving this design. So you're going to say, let's save this. We're going to call this, what was that thing called here? That was just called bracket. So this is going to be called bracket toolpaths. And then what we're going to do is we're going to add this particular bracket right in here. And I believe it is right there. We're going to go and find bracket and say select. And what it's going to do is it's going to temporarily open that bracket file and ask you, what do you want to bring in to that second file? Do you want to bring in everything? Do you want to just bring in sketches? Do you want to just bring in the bodies? You get to choose. So in this case, let's just go and pick this object, the bracket body, and say OK. Now it's going to automatically bring us back to the new file, that bracket toolpaths file. You could see I have the bracket itself in here in exactly the same position and orientation as it was in the original file. And now I get to go and add other geometry if I care about it. So maybe I want to design the stock to be a specific size or a specific shape, or maybe I want to design my soft jaws or anything else. And I'll just make this super simple for now. Maybe I want to design the stock. It's going to be whatever this size happens to be. So 5.5 by, let's say, 3 to make this easy. And I could, give this a shape. No, you probably already know this. You don't have to make a separate body like I'm doing right now for your stock. This is just trying to give you an example of something that you might want to do to add your manufacturing requirements, like your soft jaws, your vise, or whatever. So now I have my body and my part. And let's hide the stock. I don't really need to see it. We could go over to the manufacturing workspace and add all of our toolpaths here. So as an example, we'll just go and make this simple for now. We're going to go and add a facing operation. We'll go and pick a tool from my library here, and we'll filter down by our face mills. Oh, I must have unchecked that tool. There it is. We're going to go and grab our 2.5-inch face mill and add our toolpath. Now, I would want to go and do this for all the toolpaths I need. If you remember in the original file, I had like 10 operations that I was using. So I would probably, well, definitely, I would put in all operations here. And the benefit is that I have one file that has all my operations, and it also has all of the other bodies or components and stuff for manufacturing. And if I ever want to update my file, all I have to do is go over to the bracket, make the change here, and it'll update the bracket toolpaths file. And you just say right-click and say regenerate the toolpaths. All the toolpaths will update. Now, there are 2 reasons you might want to do this. The first one I already explained. All those other objects that you're using for manufacturing don't show up in the engineering model. So now when I go and I use that engineering model in other assemblies, it's nice and clean. The other reason I might want to do this is that as a machinist, I don't have the option of changing the design without the engineer or industrial designer's permission. So in this case, I bring in the body itself, and now it's like locked in as that body. In order to change it, I would have to go and edit the engineering file, right? Or ask the engineer permission to edit that engineering. Whether he or she is doing it or I'm doing it, doesn't matter. But I would need to get permission to change the shape of the design. And on the toolpaths file, all I'm doing is adding toolpaths and other construction geometry or sketches or things like that that I need to create the toolpath. But at no point am I actually changing the engineering model itself. So that's kind of a neat thing, that you're not accidentally stepping on the toes of the engineer by accidentally changing the model. Keep in mind that if I go into this bracket V5, that original bracket, I could always, as the machinist, accidentally or intentionally come in here and change something like the diameter from 3 inches to 3.1 inches, which would very much change the function of this part. So that could be good or that could be bad, but just know that if you want to make sure that your machinist doesn't have the ability to change the design itself, using a derived design is a great way to do exactly that. And this was the exact reason that Autodesk created the Derive feature. Hope that answers a couple of questions. Next, though, we're going to talk about, now that Autodesk created that feature, what else could you use it for? Both certain things that were somewhat intended and certain things that were very much not intended. And I will also show you the pros and cons with each of those choices. So let's talk about the first one. The first one is we're going to talk about when you choose the derive command, what the options are themselves. So let's go back to this bracket toolpaths file for a moment. We're going to go back to the design area. And you're going to see in my feature tree here, or my timeline, that's what we call it here at Autodesk, I have the derive feature, then I have the sketch and the extrude that I created for my stock. I'll just go and delete those for a moment here. And I'm going to go and edit the derive feature itself. Now, if you remember a few minutes ago, oh, we have to save this. Go and save. If you remember when we were choosing before, I chose the body. And I also told you that when you choose the body, it's going to show up in exactly the same position as it did in the original file. Note that it's not going to be movable once you do that. So it's going to be in exactly that position, and it's not going to be movable. And the same is going to be true if you pick sketches. So let me actually give you a better example. Let's go to a new design here. Let's save our file, and we're going to call this derive example number 2. We're going to go and insert a derived component, just like we did before. Let's go and grab, instead of the bracket, because the bracket, actually the bracket had sketches and everything in it. So let's go and grab that one. And this time, when it brings up the bracket, instead of picking the body, what I could do if I want to is pick, let's say, the sketch that created the whole thing. Just like before, what it's going to do is it's going to put that sketch in, but it's going to put it in the exact same position as the original file, and this is not movable, right? So I can't move this at all. And that could be a little frustrating. Maybe that's not what you want. So the trick that I'm going to show you all today is that instead of picking the sketch or the body, what I'd recommend is you pick the root level of the file you want to derive. And not everyone knows what that means, so let me tell you what root level means. If you look at your left bar here, you're going to see that I have my file name that's always at the top. Then I'll have, actually, let's go to the bracket. That's a better bracket. There we go. So I have my bracket, that's the top level. This is the root level, by the very top where it says the file name and the version. And then I have things like a folder for bodies, and the bodies folder could be solids, it could be surfaces, it could be sheet metal, it could be anything. And I have sketches and I have construction folders and all that other stuff. But the root level, that's the very top level. So if I go back to this derive example, let's go and delete that original derive there. Let's go and insert it again. I could also edit it. We're going to go and pick the bracket. And this time, instead of selecting the body or the sketch, I'm going to pick that root level at the very top. And automatically, it's actually going to bring in all the bodies, all the sketches, all the construction geometry. It's going to bring in everything that it can. And by the way, we do also have an option down here for bringing in parameters as well. So not everyone probably clicked on this drop-down arrow to see what parameters is going to mean, but you could bring in parameters if your design had parameters, and I'll bring it in too. I like using the root level because when I say OK, it's going to not only bring in everything, but now I could move this component and reorient it if I want to. And that to me is really, really helpful. So let's talk about the first use case for using exactly that. Now, some of you might use sketches over and over again in a design. And you may have noticed that Fusion does not yet have the ability to use a sketch multiple times in different orientations or different plans. You can't just take a sketch and have another copy of it that references the first, but is perpendicular to the first. But you can do that if you use the derive command. So let me show you an example. We're going to go to our data panel here. And here you're going to see I have a folder called Library of Shapes. And in this particular folder, I have some circle shapes, So circular tubing, this one's set to 1 inch, this one's set to 1.5 inches, this one's set to 2 inch. Then I also have some more interesting shapes, like solid extrusion. And these shapes actually came from McMaster-Carr. If you don't know how to insert McMaster-Carr components, we have a quick tip on exactly that. I'll put a link in our description, but you just say insert McMaster-Carr component and pick that component. In this particular case, I brought in the McMaster-Carr component, I projected a sketch of the profile, and then I deleted the solid geometry and I just have the sketch profile left. But I have all of these different profiles. So aluminum extrusions in a bunch of different sizes and shapes, and I also have square tubing. So let's say I want to design a table, and I want to design a table made of aluminum extrusions or square tubing or something like that. And the table, by the way, if we jump forward in time a little bit, is going to look something like this table you see on the screen. And if I hide the sheet metal tabletop, you'll see I have a welded frame. Now we don't have frame generator that you might be used to in Inventor in Fusion 360 yet, but I can still design all of this in Fusion. Now if you don't use the Derive command, what you're going to end up having to do is to draw the shape of the tube over and over and over again, and that is kind of a waste of time. So I like using the Derive command to be able to create what would traditionally be called a sketch block, or like a reusable sketch. So in this case, what I did was, and let's actually go back in time to the very beginning, see how I made this. I start off, and I'll turn on the origin so you see this. I made a construction plane that represents the tabletop. See that way up here. I then went and made a sketch on that plane. And that sketch looks like the overall shape of the table with some extra geometry that I put in there that you'll see later. Then I went and I inserted a derived component. Oh, hold on, I picked the wrong button. There it is. And the derived component is the square tubing. And in particular, what it's really going to be used for is this sketch. Zoom in here. And you can see this is the square tubing sketch from square tubing dash 1.5 inches. And let's go and look at that derive command that I used. Go and edit the derive feature. And what you'll see is I use that root level, that very top, square tubing dash 1.5 inch. And as a result, because this file only has sketches in it, it just came in with a sketch. You can see that right over here, sketch 1. And I'm going to go and say OK. Let's go back to our table here. So now I have my square tubing example, right? You can see I have my sketch up top, and my square tubing sketch is down low, real small down here. And then what I did was I created the sheet metal tabletop, and you'll see that in a moment. There it is, and then I add my flanges. But what I really care about at the moment is designing like the tubing. So let's go and hide our tabletop. I don't care about that for now. And then I made a bunch of sketches, and I'll show you those sketches here. I made a sketch that's like the cross section of the sheet metal top so that I could position my sketch exactly perfectly. And let's actually show you the sketch. This is a projection of the sheet metal top, okay? And actually, I didn't use the project tool. I used the intersect tool so that I get not just the overall silhouette, but I get where the shape intersects with this, this plane here, which happens to be the XY plane or the front plane. So I created that sketch. I did the same thing again in the other direction. So in this case, the YZ plane or the right plane. And then I went and used joints to position that component, not actually component, to position the derived sketch into the exact right spot. And if I show you exactly where this is relative to the tabletop, let's go and actually give you a cross section. Inspect, section analysis. We're going to zoom out a little bit so I could grab this plane. Now you can see this a little bit better. Perfect. So the joint that I used actually positions that sketch on the inside edge of my sheet metal table. Perfect. And now what I could do is I could actually go and extrude that, and it'll be within this component called square tubing dash 1. The difference though is that this isn't actually making the change to the original file. Remember that original file just has a sketch in it. Instead, I have a component inside this assembly that has the same name as the square tubing sketch file, but now it actually also has a solid object in it. And that object, let's go and hide our sketches and stuff, is the tube that's the correct length. Now at this particular moment, it's not like the full length and I didn't miter the corners yet, but I have a solid model of the tube. And now we could go and extrude that in one direction. I also, remember I told you earlier I had extra geometry in my top level sketch. These like lines that I put are so that I could trim or miter these corners nice and perfect. So I did that right there. And now I want to go and make another tube. But here's the thing, my table is not a perfect square. My table is rectangular, it's like longer than it is wide. So now I need another tube that is, yes, going to be the same diameter, but is not necessarily going to be the same length tube. So the cool thing about derive is that if I derive another time, now I'm going to have another component that is not going to be the same instance of the first component. If you don't know that term, an instance is like another copy of the same thing. If you edit one of them, you're editing both because they're really the same thing. So think about like a 1/4-20 pan head 1-inch long screw. It doesn't matter how many of them you have, they're all really the same thing. And if you edited the length, it would edit the length on all the screws. So in this case, I don't want that. I want a different length tube. So what I did here was I said insert derive again. It automatically puts that same sketch in the original position. You can see that somewhere down low. Let's go and show that sketch. There it is again at the origin, because that's where it was on my original file. But because I chose that root level, I could move this around just like I did the first. So the next thing that happens is I made another joint using that second sketch. And then I did another extrude, and then another extrude to chop off or miter the corner. That right here. You didn't see that. Let me go back one more step. Now with the graphics updating, you can see that I have an overlap. If I double click this, you'll see that I have like an interference between them. So then I do another extrude cut. Now that interference is gone and I have a nice perfect. And you could tell very obviously that the length of the table is, longer than it is wide. So the length of the tube is totally different. And I could rename this because now that it's derived into this assembly, I could change the name. So this is, I must have misnamed this. This is actually the long side. And then the other one is actually the short side. Oh, perfect. And then I could go and do this as many times as I need. And I also did that for the center bar. Nope, in this case, I did it for the other side. And then I'm going to go and chop that as well. And I'm going to do this as many times as I need to make my full assembly of this particular component. Now, sorry, this is a particular table. And I also did the same thing for the legs themselves so that I get legs. And for the legs, once I made the first leg, I want all the legs to actually be the same. I want them to just be multiple instances. So I made copies of the leg. I'll show you how that works. Like here, now I have one leg. I'm going to go and select the leg, and we're going to say Control C or Command C on a Mac, and then Control V or Command V on a PC. Sorry, on a Mac. You guys get it. And then I'm going to go and take this. I'm going to move it kind of off in space so it's easier to use joints. And then I'm going to go and use a joint. And let's say in this case, I might use this corner. And then I might go and pick some other corner. This isn't even going to line up perfect, but it doesn't matter for now. And I'm going to go and use the joints to get this in the right position. Happens to me. And in this case, if I change the length of the leg, it updates all the legs. So that would be, generally speaking, how you make multiple instances. But what it comes down to for this entire assembly is going to be, oh, that's why everything looks funny. Let's turn off our cross section. There we go. So what it comes down to for this particular assembly is that I have multiple components. I have my square tubing leg, and there are 4 of them. I have my square tubing center support. I have my long side, and there are 2 instances of that. And I have my short side, and there are 2 instances of that. If I show everything in here, and we go and make a drawing of this design, let's go and make a quick drawing. You're going to see that I have proper components for all of the different components, the different parts. And we're going to go and make not only a couple of different views, but I'll also show you the bill of materials as well. So here I have, let's say, a front view. We'll go and add a couple of views just so you guys see the other sides, bottom view, top view, isometric, all of that kind of good stuff. We're going to go and move that over, and we're going to add a quick table here. And right off the bat, you can see I have two square tubing pieces that are the short side, one tabletop. We have two long sides, one center support, and four legs. Exactly what I expected. The only thing that it looks like I botched up is my default material for my personal settings is set to plastic, as I design a lot of plastic parts. And it turns out I never set these parts to steel, which is why they still show as plastic. My bad. But what it comes down to is I get all my components. It shows me exactly what I'm getting. And I have my sketch driving or deriving all of my tubes. And I don't have to bother to redraw it because all I did was just reuse that separate file as many times as I needed. And the number of times you should do that should be the number of times you're going to have a different shape, whether it's different length or different height or something like that. If they're going to be unique, just derive again. So in that file that I showed you a moment ago, this table, I derived a total of 1, 2, 3, 4 times. The leg, the center leg, the long side, the short side. The other instances don't matter. You don't have to derive. Now the really crazy thing, this is where you're going to start getting into sketchy territory of what we don't necessarily recommend, but you can do, and you might still find use from that. So I'm perfectly fine showing you all of those things. And I don't think I'm going to get yelled at or anything, but I want you guys to see all the different ways that you could use Fusion, whether we officially recommend it or we expected you to use it that way or not. So in this case, I have my table made of 1.5-inch tubing, and the sketch for that tube is from another file. So what happens if I want to change my tubing for all of the different components, and I want to go from 1.5-inch to 2-inch? Well, I could do that, believe it or not. So we're going to go back to our data panel. I'm going to go and find the same file, this square tubing 1.5-inch, and we're going to go and edit this file. Now this file happens to have parameters in it. Let's go and check. We're going to go and open my parameters table, and I'll pull it up from my other screen. And you can see here that I have my width is set to 1.5. Let me actually move this down so we can see if I did this correctly. We're going to go and make that maybe 2.5 inches. And I did, perfect. So now I have 2.5-inch tubing. We're going to go and save my file. And we're going to say updated size to 2.5 inch. Perfect. Now the original file is actually called square tubing -1.5. So what I might want to do also in this particular case is go back to my data panel, find the file, and rename that as well. So let's go and change this to 2.5-inch. Perfect. And because we have built-in product data management, because we're cloud connected, and because our software is like basically magic in the background, it's going to automatically just know that that's really the file that I changed, and it's just going to fix everything, which is cool. So let's go back to our table. And now in this table, you're going to see that I'm going to get all these warnings telling me that the file that I used for the derived sketch has been updated. Do you want to stick with the original or do you want to update it? And in this case, we want to update it. And this is going to involve just a little bit of crossing my fingers, hoping that my model doesn't blow up on me, because depending on what I change, it could blow up, right? If you change something that's too big, that's just impossible to extrude the way that you were extruding it, it will give you an error. But if you designed it intelligently, chances are this is going to work great. So let's go and update our model. And I'm crossing my fingers, and I think I'm going to see all my tubing update to the right size, in this case 2.5 inches, taking a little longer than I'd like, but what it's doing is pretty awesome, right? Changing all the tubing for the entire table. And any of you out there know that when you're doing something like this, what you could do is you could actually just model all of this inside of Fusion. And when you do that all in one place, yeah, you could just update it on the spot. There's no external reference to update. But what you're lacking in that particular case is the ability to be able to change it or like reuse that in multiple different instances. Now, you probably noticed my background changed for a second there. That happens to be my little guy in my life. I actually crashed Fusion. And that happens from time to time, especially on PCs. For whatever reason, PCs tend to crash all the time. It's not as much of a Fusion thing, but PCs are notorious for that. And this is a live stream, so when stuff happens like that, it just happens. We're going to move on. You will notice, though, that the file recovery menu does come up, and that's pretty awesome. This is going to allow me to not lose a whole bunch of work that I did. So let's go and find our table. And it doesn't say, I don't actually see the table here because we didn't actually make changes to the file. That makes sense now. Let's go back over to our demo sets. Let me go find my derived table real quick. This is the table right here. And we're going to try it again because I don't give up on stuff. We already changed the size of the tubing and saved it, so that all happened. So those same update warnings that I had before, those are showing up again. We're going to go and hit the update button. And again, I'm going to cross my fingers. There we go. This time it updated perfectly. And now you could see I have the 2.5-inch tubing instead of 1.5. And all I'd have to do is update the name of my derived components if I want to. I actually don't need to have the size of the tube in the name at all. So I wouldn't even have to update it that way. But long story short, what I just showed you is that if you use a separate file that just has a sketch in it, you can use the derive command to essentially use that sketch as a design block or a sketch block. And you can create components that are different sizes from each other. You could still have multiple instances, but for something like a structure like this is fantastic. And you'll also notice if you go back to my data panel in this library of shapes that I have a library of all sorts of shapes and I could go and use whatever one I want. So let's take that a step further because we can, right? So if you use, let's say, the square tube and it turns out you want to switch to a totally different shape, you can't exactly just go to the square tube and change the size. You could change the shape itself. Chances are in your assembly that's using it, it's probably going to blow up your joints and things like that. You could fix them, not a big deal. But what you could also do if you want is you could have one file that has multiple sizes in it at the same time. So let me show you how that would work. We're going to go to New Design. And officially speaking, by the way, I made up some of these techniques. And so if you like them, please give us a thumbs up. Say you like this, let us know that you're happy with this method. If you hate this method, you could tell me that too. That's totally fine. You don't have to agree with me on everything. So here we have a new design. We're going to go and save this. And we're going to go and save this to one folder up. We're going to save this to there. And this is going to be called maybe table example again. That's fine. And here we have our table example. This time, we're going to do something very similar. Actually, we'll make this even easier. So we're going to go back to this table. We're going to go back in time to when I derived that very first shape. I'm going to go and derive a different shape instead. So now we have our sketch of the tabletop and everything. We're going to say, insert another derive. Instead of using the circular tubing, the square tubing, all of the ones that I had before, I have another example, but I want to show you this actually visually first. Let's go up one level here. Cool. I'm going to go and derive this file that you're going to see in a second. And this file is actually a kind of concoction that I've made that has multiple different tube sizes all in one file. And I chose to do this as separate sketches. So I have a sketch for the 1-inch, a sketch for 1.5 inches, a sketch for 2-inch, another sketch for 2.5, and another sketch for 3. Right, so that's what I'm using here. We're going to go back to the table right here. We're going to say insert derive. This time we're going to go and choose that exact file that I just showed you. And that's going to be square tubing multiple sizes. Again, we're going to choose the root level at the very top. That's my personal recommendation to pretty much always use the root level. And we're going to say OK. We're going to now have our component in here. And I don't actually see it. Let's go. Control B. Let's force build there. I don't see it yet. I'm going to go and save the file and see if that fixes it for us. We're going to say added derive for multiple sizes. Okay, and then I'm actually going to close this file out. I'm going to close everything. And then we're going to go and reopen that file. My gut tells me we'll there. No, we don't. All right, we're going to use a new example. We're going to go and start this one. We're going to save this one. It's going to be table example. And we're going to go and insert our derive. We do the same thing like before. We're going to go and insert derive. We're going to use squared tubing, multiple sizes. And we're going to go and choose that root level diversity. Perfect. Okay, so now everything looks the way I expected. And so if it turns out that, I want to go and make that table, so let's go and do the same method as before. So we're going to go and make just a quick construction plane up top, and we're going to go and create a quick sketch up here. Let's say it's our rectangle like that. And let's say for a moment, I want to go and extrude from this corner. So what I'm going to do is I'm going to say J for joint. I'm going to pick the origin of the square tubing, and then I'm going to come in here and pick this edge, just like that, and it puts it in a position. And this is exactly the same method that I used earlier when it was just one size tube. The difference, though, is that at this point, I could actually extrude any of these squares that I want. To make this a little easier, I could just hide or show whichever one of these I don't want to see. So if I want to go and extrude the 2-inch, I could go and say I want to extrude this from here, and I could even go, instead of distance, say to object, and we'll go to that corner. And now I have my 2.5-inch tube. And if it turns out later that I want to switch to a different size tube, I could just go and edit my feature here and hide the 2-inch sketch, show maybe a 3-inch sketch, deselect the profile, and just choose a new profile. And it will update, it'll keep the same length, and it'll just change the extrusion itself, like the profile that you are extruding. So this is yet another way that you could use the derive feature to be able to reuse sketches, but yet still be able to do multiple sizes. So you could either have a single sketch, go open the derived component and change like the main file that has the sketch, change the size and have it update your assembly or your model. Or you could actually make a file that has multiple sketches all in one place, and then when you're going to use it, just choose whichever sketch you want. This could be great for tubing examples. This could also be great for recycling symbols, right? We live in a world where, sadly, there's just too much plastic around. And if you want to go and put recycling symbols on all your products that are plastic, I would recommend it. You can make a single file that has sketches for all the different recycling symbols, and then just drag that in as a derived component, put it wherever it needs to be, and extrude that to make your shape. It's a great way to use the derive command. But we are not done. We're only 40 minutes in, and I have more ways to show you. So far I covered sketch blocks and how you could use that both for single sketches as well as multiple. You could also use this for solid objects. Now, what I'm about to show you is going to get more sketchy. And when I say more sketchy, I mean less recommended. But you can still find use for it. If you do, by all means use it. But just know that it comes with trade-offs and it could complicate things as well for you. So let's go and say I have some other tubing. Let's go back to our data panel. And this is a great example. I have a tube that I want to make different products that are all just different lengths of the same tube. Right? Maybe I'm not trying to cut them to length for like a specific table. I have 10 different sizes of this tube that I sell as is. So what I could do is actually I can make a file like this. It's called circular tube, and I called it a base model, and I have it as 1.5 OD, 6 inches long, and that's going to be like the main model that I'm working. But maybe I also want to sell a 12-inch, and I want to sell a 18-inch, and I want to sell all different other sizes. But I want a CAD model for each of them to be able to put in the assembly that I am using. So there is a way to do that. The official term for what I'm about to show you theoretically is configurations. This is not officially what we would recommend you use if you want configurations, but this is a sort of loophole to make kind of configurations. So I'm going to show you how to do that now. We're going to go and make a new file. We're going to go and save this new file right off the bat. We're going to call this one circular tube 1.5 inch OD. And this one is going to be 12 inches long, something like that. And what I could do is, instead of bringing in, I could easily bring in a sketch, extrude it to 12 inches long, save the file. I could even bring that sketch in as a derived sketch, just like I did before. But I want you to also see that you could do this kind of thing with solid models as well. This is a really basic example, but you could do it with more complex things as well. So let's go and say insert, and we're going to use derive. And we're going to go and choose the circular tube, and we're going to use the one from earlier today. That's the base model that we talked about. I could use just the body, or I could bring in the entire thing. So we're going to go and bring the entire thing by picking the root level. Or no, just to change it up so you guys could see some differences, different ways you could use the derive command, we're going to just use the body. So I'm not even bringing in the sketch, just the body. And as a result, this also won't be movable. But that's okay too, because I don't need to move this, right? I'm not going to be putting it in different places. If and when I'm going to do that, it would be in the assembly that I use this file, not in this file itself. And so let's go and look at this. I have my origin exactly where the original was. The extrusion is in the same direction as the original. What I could do here is I could say, let's use like a press pull command, modify, press pull, select this face. And I could say, you know what, I want to add another 6 inches. And this would be a perfectly suitable way to do that. If you want to see another way to do that, I'm going to go, instead of using press pull, I'll delete that for a moment. We're going to select this surface, and I'm going to say create an extrusion. I could also put in here 6 more inches, and it would give me exactly the end result that I had a moment ago. If you want to go next level awesome, you could go back to this extrude, and instead of typing in the amount you want to add, you could actually redo your distance. So I'm going to go and look here. I see distance, but for this little drop down here, you'll see that there's an option for re-anchoring. Not a lot of people know about this, but I'm going to go and say re-anchor where I'm measuring from, and I'm going to measure from this surface right there. You'll see that the value changes to 12. And now we're really measuring like the total length. So I'm going to go and put that at 12 and say OK. And now I have my total length as 12. And it does say that I have a little bit of a warning. I'm not exactly sure why that is. Let's go and fix that. Let's go and try that from scratch one more time. So we're going to go and select this surface, hit E for extrude. I'm going to go and say, let's re-anchor. And we're going to re-anchor using that very back surface. And we're going to go and type this in as 12 and hit enter. There we go. That's what I was expecting earlier. And no warnings this time. And I have the length of 12. Now I could go and save this file. And we're going to say made this 12 inches. And now I have a file that represents 12 inches. What I could also do is I could take this file and I could go and copy it. Or I could do the same process again. Really my choice. I'm going to go and say copy, and we're going to put it in the same place. And you're going to see another file show up in just a second. That's going to be a V1. That's this one. We're going to rename this file. We'll get rid of these parentheses that just got added automatically. And we're going to make this one 18 inches long. We're going to open this one up, change this extrude, and we're just going to go and change this extrude. And we're going to go and re-anchor that back, and we'll make this 18 inches. Perfect. Save that as well. We're going to say made 18 inches. There we go. So what I really did there is I sort of made configurations. Right? This is kind of like a back-end way to make configurations. And what this is going to allow me to do is to have the original file, this one that I called the base model, drives, or as I would like to say it, derives the other two components. So if I change this base model, and instead of this being 1.5 inches, I now make this 3 inches. When I hit finish, this original base model is 3 inches. I hit save. We're going to say made 3 inches. The other ones can update, but semi-automatically. I do need to go and open those files. Go and open, let's say the 18-inch one first. It's going to say that this is out of date. Hit the update button. And now I'm going to have an 18-inch, 3-inch diameter. I think that's what I picked. We'll go with that. And I save this file, and we're going to say updated diameter, something like that. So now we have one file. In this case, it's a solid model for the tube, and it can update multiple different lengths. That could also work for screws. So you could have a 1/4 20-inch screw, and maybe the first size you put in there is 1 inch long. Then you go and make a derived version of that that's 2 inches long, another one that's 3 inches long. If you change the threads on the very first file, it could propagate to all the other files. Again, this is still separate files. This would mean you have to open those files and hit the update button and then save them. So this isn't exactly what true configurations is, but this is a way to get something like configurations. And even though that's not what we at Autodesk officially recommend, I think it's important that you know that you can do that if you want to. So we covered quite a few different ways to be able to model this. And I think that covers everything that I wanted to show you guys about Derive today. Remember, Derive was meant for one thing. It was meant for being able to make a machining model that's tied to a engineering model and have that engineering model drive or derive the machining model, but you can use it for a whole lot more. That feature's only been around for about a year, right? It was released in October of last year, but you could do a whole lot of pretty incredible things with it. And I would like to see if you have other ways that you could use the derive command. Please let us know. Put it in the chat window if you're watching this live right now. Put it in the comment section of YouTube if you're watching this after the fact. And let us know how you're using Derive and the different ways that you're finding success with it. And let us know what you think. We're always eager to find out what you think about what we're showing. So today we covered a lot of different ways to derive and how you could use it, how you shouldn't use it, how you could use it where it's a little sketchy, but you could use it anyway. I hope you've learned a lot. And if you have questions that Aaron wasn't able to answer, I'll go back and answer them after the fact. But all in all, I want to thank you so much for your time today in learning new things about Fusion 360. Don't forget, with Fusion 360, you can make anything. I hope you go out and make incredible things, and I hope you have a great day. Thank you.